I'm here today with DDL's packaging engineer, Mr. Scott Levy. Scott will discuss some of the current standards in relation to distribution simulation testing. He will explain the importance of understanding the standards as well as how future changes may affect medical device manufacturers bringing products to market. Hi Scott, thank you so much for taking the time to discuss this topic with us today. To start off, could you please give us a quick overview of the standards for distribution simulation, ISTA 3A and ASTM D7386?
Well, thanks Claudia for having me. When we talk about a multitude of test methodologies, there are a lot of different test methodologies that medical device manufacturers can utilize on a daily basis to validate their shipping or performance testing of their goods. Two of the most robust test procedures out in the industry right now are ISTA Project 3A as well as ASTM D7386. They both address what basically transpires in a normal distribution environment: drop testing, vibration testing, compression testing. Both test methodologies are pretty close, or I'll almost call them identical to one another. It's just a different flavor, potato and potato. When looking at these two test methodologies for medical device manufacturers, the one thing you really want to take into close consideration is the stack vibration and how realistic that is for the medical device industry. We typically know on a daily basis that when a FedEx truck comes and picks your samples up and they're very light, the light stuff gets packed on the top and the heavy stuff gets packed on the bottom. Now, in executing these validations and you're running a stack vibration, you have a failure. What do you end up doing? You end up increasing the cost to your shipper, you increase the cost in the overall packaging, and so forth like that. So both test procedures are wonderful for evaluating distribution simulation. In my opinion, do I feel it is necessary for medical device manufacturers to utilize this? No.
What are some of the pitfalls of both methodologies?
The primary pitfall, like I was saying, is the stack vibration portion. It truly wreaks havoc. We've had many customers try to execute this as a worst case scenario, but it's not realistic to what they see every single day. Now we know with medical devices that these are sterile and extremely important. If a sterile device ends up at the hospital or a distribution center and the box is crushed, what's going to happen? They're going to automatically send this back as defect. So, like I was saying, when you're executing this type of methodology and you're having failures under laboratory constraints, what do? Especially in the economic times that we're dealing with right now, everybody's trying to cut costs in packaging, reuse, recycle, and so forth like that. And in this situation, it's a tough scenario to try to execute for medical device manufacturers. But like I said, both of these test procedures are fantastic, but I don't think it's just strictly meant for medical device. These test procedures can be used for all genres of the industry.
Okay. Why are the ISTA procedures not considered consensus standards?
In order for a test methodology to become a consensus standard by the FDA, it needs to be drawn out in an open and transparent process. If you take a look at ASTM procedures, SEN, ISO, all the procedures itself are done in a publicly held organization. And in order for a test procedure to become a consensus standard, it needs to be drawn out in an open and basically open and public forum. It needs to be a transparent process.
Okay, great. Do you see any changes being made to the current standards for distribution simulation, and how will that affect the medical device manufacturer?
I don't necessarily think it's going to affect the medical device manufacturer. I think it's simply going to help them a little bit further. For a prime example, ASTM D4169 it's a great test procedure, but it's probably the most common test procedure for evaluating goods through dynamics. And what ASTM is currently working on is taking a look at the vibration profile spectrums. If you've ever ran ASTM D4169 for vibration, you have different assurance levels you can execute at. Assurance level 1 is the most severe, assurance level 2 is pretty much on task for what's going on in the real world, and assurance level 3 is a less severe test. What's transpiring in ASTM right now is they're going out and looking for real world data to incorporate into those vibration spectrums. What that'll do for the medical device manufacturers is give them a little bit more real-world guidance for the vibration spectrums that they're going to be using, in D4169.
Wonderful. Well, thank you so much for your time today. I appreciate you coming in. Thank you.
My pleasure. Thanks, Claudia.